Today we will discuss about fibers. Fibers are the structural parts of plants and are found in all plant-derived foods, vegetables, fruits, grains and legumes. Most fibers are polysaccharides. Fibers in plant foods, the non-starch polysaccharides that are not digested by the human digestive enzymes. Although some are digested by the digestive tract bacteria, fibers is a type of carbohydrate that the body can't digest. Most carbohydrates are broken down into sugar molecules called glucose. Fiber cannot be broken down into sugar molecules and instead it passes through the body undigested. Fibers help regulate the body's use of sugars, helping to keep hunger and blood sugar in check. Children and adults need at least 25 to 35 grams of fiber per day for good health. Fiber is one of the main reasons whole plant foods are good for you. Growing evidence shows that adequate fiber intake may benefit your digestion and reduce your risk of chronic diseases. Many of these benefits are mediated by your gut microbiota, the millions of bacteria that live in your digestive system. Not all fiber is created equal. Different types have the different health effects. As you all know, dietary fiber is a non-digestible carbohydrate found in foods. It's split into two broad categories based on its water solubility. Fibers different from the starches in that the bonds between their monosaccharides cannot be broken down by the digestive enzymes in the body. Fiber contribute no monosaccharides and therefore little or no energy to the body. For these reasons, fibers are often described as non-starch polysaccharide. The non-starch polysaccharide fibers include cellulose, hemicellulose, pectins, gums, and mucilages. Fibers also include some non-polysaccharides such as lignins, chitins, and tannins. Each of the fiber has a different structure. Most contain monosaccharides but differ in the type they contain and in the bonds that link the monosaccharides to each other. Fiber is an important nutrient that comes from plant. It's sometimes called roughage or bulk. Fiber comes in two forms, soluble and insoluble. Getting the right amount of both can aid digestion and may even lower your risk for certain chronic diseases. When you eat, your body breaks food down into nutrients it can use, but it can't digest or absorb fiber, which is actually a good thing. Fiber stays mostly intact for its journey through your body. Soluble fibers dissolves in water and other body fluids when it forms a gel-like material as it passes through. Once it makes it to the colon, it feeds your gut bacteria. Healthy gut bacteria are linked to a host of health benefits, including some protection against obesity and its related conditions such as diabetes. Insoluble fibers does not dissolve in fluids. It absorbs them and sticks to other material to form stools. This process leads to softer, bulkier, and more regular stools. A more powerful and helpful way to categorize the fiber is as fermentable versus non-fermentable, which refers to whether friendly gut bacteria can use it or not. It's important to keep in mind that there are many different types of fiber. Some of them have important health benefits, while others are mostly useless. There is a lot of overlap between soluble and insoluble fibers. Some insoluble fibers can be digested by the good bacteria in the intestine, and most foods contain both soluble and insoluble fibers. The bacteria that live in the human body outnumbers the body's cell 10 to 1. Bacteria live on the skin, in the mouth, and in the nose, but the great majority live in the human gut, primarily the large intestine. 500 to 1000 different species of bacteria live in the intestine, totaling about 38 trillion cells. These gut bacteria are also known as the gut flora. This is not a bad thing. In fact, there is a mutually beneficial relationship between you and some of the bacteria that live in your digestive system. You provide food, shelter, and a safe habitat for the bacteria. In return, they take care of some things that the human body cannot do on its own. Of the many different kinds of bacteria, some are crucial for various aspects of your health, including weight, blood sugar control, immune function, and even brain function. You may wonder that this has to do with fiber. Just like any other organism, bacteria need to eat to get energy to survive and function. The problem is that most carbohydrates, proteins, and fats are absorbed into the bloodstream before they make it to the large intestine, leaving little for the gut flora. This is where fiber comes in. Human cells don't have the enzymes to digest fiber, so it reaches the large intestine relatively unchanged. Intestinal bacteria do have the enzymes to digest many of these fibers. This is the most important reason that dietary fibers are essential for the health. They feed the good bacteria in the intestine, functioning as prebiotics. In this way, they promote the growth of good gut bacteria, which can have various possible effects on health. The friendly bacteria produce the nutrients for the body, including short chain fatty acids such as acetate, propionate, and butyrate, of which butyrate appears to be the most important. These short chain fatty acids can feed the cells in the colon, leading to reduced gut inflammation and improvements in digestive disorders such as irritable bowel syndrome, Crohn's disease, and ulcerative colitis. When the bacteria ferment the fiber, they also produce gases. This is why high fiber diets can cause flatulence and stomach discomfort in some people. These side effects usually go away with the time as your body adjusts. Certain type of fibers can help you lose weight by reducing your appetite. Fibers can soak up water in the intestine, slowing the absorption of nutrients and increasing feelings of fullness. This depends on the type of fiber. Some types have no effect on weight, while certain soluble fibers can have a significant effect. High fiber food tend to have a lower glycemic index than refined carbohydrate sources which have been stripped of most of their fibers. Soluble fibers in your carbohydrate containing meals may cause smaller spikes in blood sugar. This is important, especially if you are following a high carbohydrate diet. The fiber can reduce the likelihood of the carbohydrates raising your blood sugar to harmful levels. If you have blood sugar issues, you should consider reducing your carbohydrate intake, especially your intake of low fiber, refined carbohydrate such as white flour and added sugar. Viscous soluble fiber can also reduce your cholesterol levels. The effect is not nearly as impressive as you might expect. One of the main benefits of increasing the fiber intake is reduced constipation. Fiber is believed to help absorb water, increase the bulk of stool, and speed up the movement of stool through the intestine. Fiber increase the water content of your stool, has a laxative effect, while fiber that adds to the dry mass of stool without increasing its water content may have a constipating effect. Soluble fibers that form a gel in the digestive tract and are not fermented by the gut bacteria are often effective. A good example of a gel-forming fiber is psyllium. Other types of fibers such as sorbitol have a laxative effect by drawing the water into the colon. Prunes are a good sources of sorbitol, which have the laxative effects. Choosing the right type of the fiber may help your constipation, but taking the wrong supplements can do the opposite. Colorectal cancer is the third leading cause of cancer deaths in the world. Whole, high fiber foods like fruits and vegetables and whole grains contain various other healthy nutrients and antioxidants that may affect cancer risk. It is difficult to isolate the effects of fiber from other factors in healthy, whole food diets. Fiber may help keep the colon well healthy. Dietary fibers have various health benefits. Not only does it feed your gut bacteria, but fermentable fiber also forms short chain fatty acid. Viscous soluble fibers also very helpful. Gut bacteria are well known for their effect on chronic inflammation. They produce nutrients for your body, including short chain fatty acid. They feed the cells in your colon. This leads to reduced gut inflammation and improvements in related inflammatory disorders. While acute inflammation is beneficial because it helps your body fight foreign invaders and repair damaged cells, chronic inflammation is a serious concern because it may begin to attack your body's own tissues. Chronic low level inflammation plays a major role in almost every chronic disease, heart diseases, Alzheimer's disease, and metabolic syndromes. Many viscous fibers may reduce your appetite, helping you eat less. You need to be in a calorie deficit to lose weight. This means that more calories need to be leaving your body than entering it. Counting calories help many people, but it may not be necessary if you choose the right foods. Anything that reduces your appetite can decrease your calorie intake. With less appetite, you may lose weight without even having to drink about it. The more viscous the fiber, the better it is at reducing the appetite and food intake. The viscosity of a substance refers to its thickness and stickiness. Honey is much more viscous than water. It is the example of the thickness and the stickiness. Viscous soluble fibers such as pectins, beta-glucans, psyllium thickens the water, forming a gel-like substances that sits in your gut. This gel slows the emptying of your stomach, increasing the digestion and absorption time. It is an organic compound and the most abundant biopolymer on Earth. It is a complex carbohydrate or polysaccharide consisting of hundreds to thousands of glucose molecules linked together to form a chain. While animals don't produce cellulose, it is made by plants, algae, and some bacteria and other microorganisms. Cellulose is the main structure molecule in the cell wall of plants and algae. A French chemist, Anselm Pine, discovered and isolated the cellulose in 1838, determined the chemical formula of the cellulose. In 1870, the first thermoplastic polymer celluloid was produced by the Hayat Manufacturing Company using the cellulose. Cellulose was used to produce rayon in the 1890s and cellophane in 1912. Hermann Staudinger determined the chemical structure of the cellulose in 1920. In 1992, Kobashi and Shoda synthesized cellulose without using any biological enzymes. Cellulose forms via beta-1,4 glycosidic bonds between D-glucose units. Starch and glycogen form by alpha-1,4 glycosidic bonds between glucose molecules. The linkages in cellulose make it a straight-chain polymer. The hydroxyl groups on the glucose molecules form hydrogen bonds with oxygen atoms, holding the chains in place and conferring high tensile strength to the fibers. In plant cell walls, multiple chains bond together to form microfibrils. Pure cellulose is odorless, flavorless, hydrophilic, insoluble in water, and biodegradable. It has melting point of 467 degrees Celsius and can be degraded into glucose by acid treatment at high temperature. Cellulose is a structural protein in plants and algae. Cellulose fibers are enmeshed in a polysaccharide matrix to support plant cell walls. Plant stems and wood are supported by cellulose fibers distributed in a lignin matrix, where the cellulose acts like reinforcing bars and the lignin acts like concrete. The purest natural form of cellulose is cotton, which consists of over 90% cellulose. Wood consists of 40 to 50% cellulose. Some types of bacteria secrete cellulose to produce biofilms. The biofilms provide an attachment surface for the microorganisms and allow them to organize into colonies. While animals cannot produce cellulose, it is important to their survival. Some insects use cellulose as a building material and food. Ruminants use symbiotic microorganisms to digest cellulose. Humans can't digest cellulose, but it is the main source of insoluble dietary fiber, which affects nutrient absorption. Many important cellulose derivatives exist. Many of these polymers are biodegradable and are renewable resources. Cellulose-derived compounds tend to be non-toxic and non-allergic. Cellulose derivatives include celluloid, cellophane, rayon, cellulose acetate, cellulose triacetate, methyl cellulose, cellulose sulfate, ethylose. The principal commercial use for cellulose is paper manufacturing, where the kraft process is used to separate cellulose from the lignin. Cellulose fibers are used in the textile industry. Cotton, linen, and other natural fibers may be used directly or processed to make rayon. Microcrystalline cellulose and powdered cellulose are used as drug fillers and as food thickeners, emulsifiers, and stabilizers. Cellulose in liquid filtration and thin layer chromatography are also used. Cellulose is used as building material and electrical insulator. It is used in everyday household materials like coffee filters, sponges, glues, eye drops, laxatives, and films. While cellulose from plant has always been an important fuel, cellulose from animal waste can also be processed to make butanol biofuels. Cellulose is one of a number of heteropolymers, such as arabinoxylase, present along with cellulose in almost all plant cell wall. Cellulose is crystalline, strong, and resistant to hydrolysis, and hemicellulose are branched, shorter in length than cellulose, and also show a propensity to crystalline. They can be hydrolyzed by the dilute acid or base, as well as myriad of hemicellulose enzymes. Diverse kinds of hemicellulose are known. Important examples are xylane, glucuronoxylane, arabinoxylane, glucomannan, and xyloglucan. Hemicellulose are polysaccharides, often associated with cellulose, but with distinct compositions and structures. Cellulose is derived exclusively from glucose. Hemicellulose are composed of diverse sugars and can include the five carbon sugars xylose and arabinose, the six carbon sugar glucose, mannose, and galactose, and the six carbon deoxy sugar rhamnose. Hemicellulose are composed of all these diverse group of sugars. Hemicellulose contain most of the D-pentose sugars and occasionally small amounts of L sugars as well. Xylose is in most cases the sugar monomer present in the large amount. In softwoods, mannose can be most abundant sugar. Not only regular sugars can be found in the hemicellulose, but also their acidified forms of glucuronic acid and galacturonic acid can be present. Unlike cellulose, hemicellulose consists of shorter chains, 500 to 3000 sugar units. Each polymer of cellulose comprises 7,000 to 15,000 glucose molecules. Hemicellulose may be branched polymers, while cellulose is unbranched. Hemicellulose are embedded in the cell walls of plants, sometimes in chains that form a ground. they bind with pectin to cellulose to form a network of cross-linked fibers. Based on the structural differences like backbone linkages and site groups, as well as other factors like abundance and distributions in plants, hemicellulose can be characterized into four groups. Xylene. Xylene usually consists of a backbone of beta-1,4-linked xylose residues and can be further divided into homoxylenes and heteroxylenes. Homoxylenes have a backbone of D-xylopyranose residues linked by beta-1,3 or mixed beta-1,3 or 1,4 glycosidic linkages. Homoxylenes mainly have structural functions. Heteroxylenes such as glucuronoxylenes and complex heteroxylenes have a backbone of D-xylopyranose and short carbohydrate branches. For example, glucuroxylane has a substitution with alpha-1,2 linked glucuronosyl and 4-O-methyl gluconosyl residues. Mannans are another example of the hemicellulose. The Mannan type hemicellulose can be classified into two based on their main chain differences, galactomannans and glucomannans. Galactomannans have only beta-1,4 linked D-mannopyranose residues in linear chains. Glucomannans consist of both beta-1,4 linked D-mannopyranose and beta-1,4 linked D-glucopyranose residues in the main chains. As for the side chains, D-galactopyranose tend to be 6 linked to both types as the single side chains with various amounts. The conformation of the mixed link glucans chains usually contains blocks of beta-1,4 D-glucopyranose separated by single beta-1,3 D-glucopyranose. The population of beta-1,4 and beta-1,3 are about 70 to 30%. Xyloglucans have a backbone similar to cellulose with alpha-D xylopyranose residues at position 6. To better describe different side chains, a single letter code notation is used for each side chain type. The two most common type of the xyloglucans in plant cells are XXXG and XXGG. Hemicellulose are synthesized from sugar nucleotides in the cell's Golgi apparatus. As a polysaccharide compound in plant cell walls, similar to cellulose, hemicellulose helps cellulose in the strengthening of plant cell walls. Hemicellulose interacts with the cellulose by providing cross-linking of cellulose microfibrils. Hemicellulose will search for voids in the cell wall during its formation and provide support around the cellulose fibrils in order to equip the cell walls with the minimum and maximum possible strength it can provide. Hemicellulose dominates the middle lamella of the plant cells, unlike cellulose, which is primarily found in the secondary layers. This allows for the hemicellulose to provide middle ground support for the cellulose on the outer layer of the plant cells. In few cell walls, hemicellulose will also interact with the lignin to provide structural tissue support of more vascular plants. Pectin is a unique fiber found in fruits and vegetables. It is soluble fiber known as a polysaccharide, which is a long chain of indigestible sugars. When heated in the presence of liquid, pectin expands and turns into a gel, making it a great thickener for jams and jellies. It also gels in your digestive tract after ingestion, a function that provides the numerous health benefit. Most pectin provides made from the apples, citrus peels, both of which are rich sources of this fiber. Pectin is a fiber and contain almost no calories. It's key ingredient in jams and jellies and used as a soluble fiber supplement. Pectin provides little nutrition. One fluid ounces, which is round about 29 grams of liquid pectin, contains 3 kilocalories, 1 gram of carbohydrates, 1 gram of fiber. No protein content and no fiber content they contain. Powdered pectin has a similar nutrient content. Neither the liquid nor the powdered form contain significant amounts of vitamins and minerals, and all of its carbohydrates and calories come from fiber. Some products called pectin dry mixes contain added sugars and calories. These mixes can also be used to make the jams and jellies. Pectin is primarily used in food production and home cooking as a thickener. It is added to commercially produced and homemade jams and preservatives. It may be added to flavored milk and drinkable yogurt as a stabilizer. For home kitchen use, pectin is sold as a white or light brown powder or a colorless liquid. Pectin is also used as a soluble fiber supplement, which is often sold in capsule forms. Soluble fiber may help relieve the constipation, lower cholesterol and triglycerides levels, improve blood sugars, and promote the healthy weight. The fiber is key component of time release coating used in some medications. Pectin lowered your blood sugar level and improved blood sugar related hormone functions, which could manage type 2 diabetes. Pectin may also improve blood fat levels by binding with cholesterol in your digestive tract to keep it from being absorbed, which could lower your risk of heart diseases. Pectin has killed colon cancer cells. Fiber This type of fiber helps decrease inflammation and cellular damage that can trigger colon cancer cell formation. Pectin killed the some other type of the cancerian cells including breast, liver, stomach and lung cancer cells. Pectin may also promote a healthy body weight. Fiber intake increased linked to a decreased risk of overweight and obesity. Fiber is filling, and most high fiber food are lower in calories than low fiber foods like refined grains. As a soluble fiber, as a soluble fiber with unique gelling properties, pectin aids digestion in many ways. Soluble fibers turn into gel in your digestive tract in the presence of water. They soften the stool and speed the transit time of material through the digestive tract, reducing constipation. Soluble fiber is a prebiotic, a food source for the healthy bacteria living in your gut. Pectin has few side effects that it can affect digestion. It may cause gas or bloating in some people. You should avoid it if you are allergic to the food it was sourced from. Most commercial products and supplements are made from the apples or citrus peels. One way to add the pectin to your diet is to eat more foods that are high in this fiber, such as apples. Nearly all vegetables and fruits contain some pectin. So, eating a variety of plant foods is an excellent way to boost your intake. Almost almost most jellies and jams are made with pectin. Eating more jams or jellies is not a good way to include the more pectin in your diet. Jams and jellies contain only small amounts of the fiber and are high in the sugar and calories. They should be eaten in moderation. You can purchase the pectin in supplement form, usually as capsules. These capsules are often made from apples or citrus peels. Pectin is complex polysaccharide consisting of esterified D-galacturonic acid residues in an alpha-1,4 chain. The acid group along the chain are largely esterified with methoxy groups in the natural product. There can also be acetyl groups present on the free hydroxy group. The galacturonic acid main chain it also has the occasional rhamnose group present which disrupts the chain helix formation. Pectin is a complex polysaccharide consisting mainly of esterified D-galacturonic acid residues. There can also be acetyl groups present on the free hydroxy group. The galacturonic acid main chain also has the occasional rhamnose group present which disrupts the chain helix formation. Pectin is also known to certain other natural sugars which are present in side chains. The most common side chain sugars are xylose, galactose, and arabinose. The side chains tend to occur in groups and have led to the description of the pectin molecules as having hairy and smooth regions. Commercial pectins are categorized according to their methoxy content and whether they form gels quickly or slowly. Roughly speaking, pectins can be split into high methoxy pectins, 50% esterified, and low methoxy pectins, less than 50% esterified. Low methoxy pectins can also be amidated or not. Are gums and mucilages. Gums are polysaccharide, complex carbohydrates, soluble in fiber, which can form gels and mucilages. They have high molar mass and can be formed by galactose, arabinose, rhamnose, xylose, and galacturonic acid, among others. They have gelling characteristics, thickening, moisture retention, emulsification, and stabilization. Polysaccharides are widely used in the formation of food products due to the wide versatility. These are very versatile biopolymers, extensively used in the food sector as ingredient or additive, which fulfill several technological and sometimes nutritional functions. This versatility is intrinsically related to their molecular composition, which gives these polysaccharides certain properties such as gelling, stabilization, emulsification. In the food industry, they are widely used in confectionery as ice cream stabilizers, food emulsions, in the microencapsulation of flavor and dyes, clarifiers, and beverages stabilizers. Information on the molecular structure, thermal stability, interaction with water, and their rheological behavior are essential knowledge for prospecting and developing the applications for each type of polysaccharide. Yucata plant secretes gums from the site of the injury, like the other fibers. gums are composed of various monosaccharides and their derivatives. Gums such as guar gum, gum arabica are used as additive by the food industry to thicken the processed foods. Mucilages are similar to the gums in structure. They include psyllium or carrageenan, which are added to food as stabilizer. Is a thick, gluey substance produced by nearly all plants and some microorganisms. These microorganisms include protists, which use it for their locomotion. The direction of their movement is always opposite to that of the secretion of the mucilage. It is a polar glycoprotein and an exopolosaccharide. Mucilage in plants play a role in the storage of water and food, seed germination, and thickening members. Cacti and flax seeds are especially rich sources of the mucilages. Mucilages is edible. It is used in medicine as it relieves irritation of mucous membranes by forming a protective film. It is known to act as a soluble, viscous dietary fiber that thickens the fecal mass, an example being the consumption of fiber supplements containing psyllium seed husk. Marshmallows were made from the extract of the mucilaginous root of the marshmallow plant. The inner bark of the slippery elm, a North American tree species, has long been used as a demulcent and cough medicine, and is still produced commercially for that purpose. Mucilage mixed with water has been used as a glue, especially for bonding paper items such as labels, postage stamps, and envelope flaps. Different types and varying strength of mucilage can also be used for other adhesive applications, including gluing labels to metal cans, wood to china, and leather to paperboard. During the fermentation of soybeans, extracellular enzymes produced by the bacterium natto react with soybean sugars to produce the mucilages. The amount and viscosity of the mucilage are important natto characteristics, contributing to the unique taste and smell. The presence of the mucilages in seeds affects the important ecological processes in some plant species, such as tolerance of water stress, competition, facilitation of germination through attachment of soil particles.
A carbohydrate and an irregular phenolic compound that provide structure and support for plant health and life. Lignin in plants is found in the between the cell walls of the plant, serving the bind cells and lend durability to plant matter. It's vital. Major biological component of all manners of plants, from woody trees to plant with freestanding stems to crunchy vegetables. In fact, it is the second most common biological material on the planet. The first being cellulose, which makes up the cell walls that lignin supports. Lignin is a huge source of sequestered carbon, accounted for 30% of all biological carbon and up to 20% of the dry weight of all woody plants. This also make it one of the most abundant sources of renewable carbon on earth. Lignin is the main component of the fiber in a person's diet. There is lignin in the wood in that person's house. The wood lignin is a combination of the Latin lignum, which means wood, and the scientific suffice, in which denotes a neutral substance. Lignin in word is probably the most obvious, abundant illustration of the definition of lignin and what that compound does. Is lignin a carbohydrate? Yes, as it's composed of carbon, oxygen, and hydrogen. It also a polymer. creating huge irregular branches within the structure of a plant. There are three broad classes of lignins found in three different types of plants: softwoods, hardwoods, grasses, and annual plants. Lignins are first formed into monolignols from coniferyl Cinnapial alcohols, which are polymerized by oxidation into dilignols. The dilignols connect end to end to form a polymer, sometimes forced to branch from their benzyl groups by other chemical interactions to create the random structure. Lignin is formed when simple plant molecules are put together to create a lignin molecule, which then connects with other lignin molecules to form a chain. One important biological property of the lignin is that, unlike some other carbohydrates, it is not soluble in water or alcohol. Lignin in plant life is varied and vital. It provides support, structure, and durability. Lignin as a polymer branches throughout the body of a plant, binding its cells and fitting between cell walls. Bryophytes, the family of small, mossy plants that do not have a vascular structure, also do not have any lignin, while trees tend to have the highest amounts. Lignin is vital to the growth and development of plants, as it gives strength to stalks, stems, limbs, and branches. It is directly involved with crop yields because stronger branches can hold bigger fruits without snapping and keeping plants upright in adverse conditions. Water loss in a plant can be mitigated by the presence of lignin, as it serves to lock water within cell walls and to provide a path for water transport within the plant.